Hello everyone, I'm excited to be here today to talk to you about the next step in our biggest struggle as humankind, our ability to continuously feed the next generations without ruining our soils or using our natural resources. This is a struggle that has been with us from the beginning of mankind, and every time we were able to succeed and prevail. It's remarkable to think that in 1900 we fed 2 billion people, and today we're feeding 8 billion people. And we're doing that by only farming 30% more arable land. All of these incredible accomplishments that changed the way we farm were made possible by different technologies that improved our farming practices. From machinery that replaced the need for human labor in the field, to synthetic fertilizers and pesticides that were able to better nurture and protect crops, to advances in biotech and genetics that enabled us to unlock the value of plant genetics. Starting with 1900s, companies like John Deere re-envisioned and reimagined the way we work the fields by introducing farm machinery that was able to replace the need for human and animal back-breaking labor and making farming significantly more efficient. In fact, in 1900s, 41% of the population was working in agriculture. Today, that number is 1.9%. We're producing a lot more food with way fewer people. In chemistry, Nobel Prize winners Haber and Bosch were able to figure out the alchemy of air. They literally understood how to extract nitrogen from the air and make it into fertilizers that crops can take up for nutrition. By unlocking us from natural, limited fertility products, they were able to adequately nurture crops and increase yields significantly. At the same time, scientists were able to synthesize chemistry to protect crops from weeds, pests, and diseases, significantly reducing the risk in farming. It's hard to overstate how important synthetic fertilizer was to humanity. It is often stated as one of the inventions that saved the most lives in human history. Next came the Green Revolution, led by Norman Borlaug. Norman Borlaug understood plant genetics and was able to breed crops that were short in stature and were pest resistant. These crops, with adequate irrigation, fertilization, and crop protection, were able to yield 3 times more than the predecessors. This was a huge innovation that was able to save billions of people from starvation. In fact, countries like Mexico, India, and Pakistan went from food shortages to food surpluses within 3 years by implementing these practices and crops. The industrialization of our farming system has unlocked a huge bounty for humanity. In the US alone, corn yields went from 20 bushels an acre in 1900s to over 150 bushels an acre today. That is a whopping 650% increase in productivity just because of better practices and equipment. We stand on the shoulders of giants, but feeding our growing population with industrial agriculture came at a cost, with soil erosion, loss of biodiversity, and the pollution of our water resources and air. We didn't understand that a system that heavily relies on synthetic pesticides and fertilizers will come with an environmental cost. It seems obvious in hindsight, yet the climate crisis has only been widely acknowledged in the last 2-3 decades. We only understood that soils are alive in 2000, because before that we just thought about it as dirt. And how long did it take us to understand that cigarettes are bad and seatbelts are good? But that was then, and now we know. We know that our system that relies on pesticides and fertilizers is degrading our soils and creating pollution and contributing to climate change. We know that agriculture emits 15 to 18% of global emissions every year, mostly in the form of methane and nitrous dioxide. And that just the production and utilization of synthetic fertilizer emits 2.6 gigatons of CO2 equivalents every year, more than aviation and shipping combined. The truth is that even with all of our efficiency gains, there's still glaring inefficiencies in our current farming system that we can no longer afford. Each year, farmers globally spend $300 billion on synthetic fertilizers and pesticides. Yet 30 to 50% of fertilizers are over-applied on crops that don't need more nutrients. That excess fertilizer runs off into the soil and pollutes our freshwater resources. At the same time, 50 to 75% of pesticides are misapplied. With the wrong timing, they actually provide no value to farmers in the field. Meanwhile, the UN estimates that we lose 40% of our global food production every year to diseases and pests. Think about it. We are losing half of our food production every year. Or in another way, we can produce almost twice as much food without farming 1 more inch of soil, just by protecting our crops better. It's very clear that we need another green revolution. But this time, we need to work with nature and not against it. We need to find a way to cultivate crops without ruining our water and soil resources, so we can continue to feed the growing populations for infinity. We need to go beyond the green revolution and into an evergreen revolution. We must move past the impacts of industrial agriculture without condemning billions of people to starvation. The way to do that is to enable large-scale farming of thousands of acres while treating each individual plant based on their own needs. The solution needs to be labor efficient, as less than 2% of the population chooses to farm. It needs to be high yielding, because we can't afford to reduce yield and deforest more land for agricultural cultivation. And it has to work with nature to reduce the dependency on fertilizers and pesticides, so we can keep our soils healthy and useful for future generations. The good news is that we're already in the midst of the Evergreen Revolution. Because of technologies that have matured and reduced in costs in other industries like hardware, software, and biotech, they're now converging in agriculture in main areas that are enabling us to transition: infrastructure technology, field technologies, and biotech. Field tech covers all of the equipment that's in the field. The most famous example is the tractor, that's over the last 10 years become way smarter and is now acting as an agronomist in the field. With cameras, sensors, and image processing capabilities, it can scan the plants and understand how to treat them on an individual level. Infrastructure technology is necessary to enable the smart equipment in the field. Everything from connectivity to cloud computing to machine learning and AI. A great example of the convergence of smart equipment and infrastructure technology is See and Spray technologies that have been rolled out in the last few years. Now sprayers equipped with cameras and sensors and image processing capabilities can go through the field, scanning plants and differentiating between weeds and plants, only applying herbicide on weeds and reducing 70% of the need for herbicide. Last but not least comes biotech. Developments in recent years in synthetic biologies are making plant engineering better, faster, and cheaper. Hardware and software has gotten us so far, but at the end of the day, farming is a biological living system. In order to unlock the full potential of our farming system, we need to work with biology. Systems like See and Spray are already providing value through visible problems like weeds. Biology will unlock the next set of opportunities by making the invisible problems, like pathogens, diseases, lack of nutrients or water, visible. This new data set will contribute knowledge that will help farmers generate 70 billion worth of new value every year. By now, you're probably wondering, how do you make the invisible visible? We do this by creating crops that can tell us what they need. And that's exactly what my company, InnerPlant, does. Let me explain how we do this. All plants react naturally to their environment. For example, if a plant is eaten by bugs, it's going to start producing a compound in its leaves to make it taste bad. If it doesn't have enough nitrogen, it mobilizes its roots in order to extract nitrogen from the soil better. And these reactions are both early and specific. The problem is that they're invisible to us because they happen on the physiological level of the plant. This is where InnerPlant comes in. We recode the plant's DNA, literally adding a line of code, telling the plants when you're starting to react to the stressor in the environment, start producing a new protein in your leaves that fluoresces. That protein then creates an optical signal we can see in broad daylight in large-scale fields. As you can see in this image, these are the two plants from before, but in controlled lighting you can see that the sensor plant glows while the other doesn't. Our signal can be detectable from as far as satellites to drones to the equipment running through the field. Collecting data directly from plant physiology helps us work with nature to better treat our crops. Instead of applying chemicals in advance everywhere like we do today, we'll be able to know exactly where stress or infection is starting in the field, and only applying fertilizers and pesticides on crops that need it when they need it. This will both increase yields for farmers and reduce costs and reduce the risk of farming tremendously. Data alone is not enough. We wanted to design a system that works for farmers just like it works for nature, which means working with the entire industry to create a fully integrated, seamless solution for farmers, so that when they plant seeds, they're going to grow sensors without having to do anything different. And we have industry leaders like Deere and Syngenta already on board and committed to this future. To give you an example, based on our first product, a soybean signaling fungal pressure, how is this going to come together? When farmers buy seeds, our technology is going to be embedded in the seed. So when they start growing the crops, we can start collecting that data and the system comes to life without the farmers having to do anything else or different. Once we see an infestation in the field, that information is going to be fed into the farmer management systems that exist, bringing them to life with better data. From there are products that are designed to work optimally with early detection and early action systems like ours. And the equipment then, with the right product, can go out to the infected area in the field, and with sensors and cameras that are able to see the fluorescent signals, can scan every individual plant and only apply chemistry on the plants that are infected and need it. The great news is that what's good for farmers is good for the world as well. Farmers benefit from an increase in yields and reduction in cost. The environment benefits from reduction of unnecessary chemicals that then increases the biodiversity above and below ground. By getting our soils healthier, we can increase the ability of the soil to sequester carbon and act as a massive carbon sink. And the reduction of chemistry means less emissions and pollutions in our agricultural sector. Everything we've accomplished so far has been a miracle of ingenuity and science, but it is now time for the next revolution, the Evergreen Revolution. It's time for us to figure out how to increase productivity without creating social or environmental harm, so we can continue to feed the population of the world in perpetuity. Thank you.